Welcome back. Last time we left off here, I said to take a look at these questions yourselves, and then we'd go over them when we pick back up. Okay, so from earlier in the year, and again, a review in this unit, what are particles with a charge called? Well, they're called ions. And how do ions form? During chemical bonding, we said they form by gaining or losing electrons and becoming charged particles. But in the process of dissolving in ionization, the polar ends of water are attracted to the opposite charge ions, and the ions float away with the water. So they were a neutral compound when they were bonded together, and then as the water dissolves them, they ionize and break back into separate ions as they float away with the water molecules. So just for review, I put this picture of this salt crystal dissolving here, and the sodiums have the positive charges, they're plus, and the chlorines have the negative charges, they're negative. And you can see these two, the red ends of the water, which is the oxygen, and the negative end are coming towards this sodium, and then the positive sodium, and there'll be enough negative waters to cancel out this positive charge. So because it's now canceled out, it's no longer attracted to the chlorine over here, so it'll just float away with the waters like this one did down here, and this chlorine did up here with the positive ends of the water, the oxygen ends surrounding it. So it kind of makes its own neutral particle, you kind of think of, as it ionizes and floats away. So here's another picture of that. The positive end of the sodium is canceled out by these negative ends of the water, and the negative chlorine is canceled out by the positive ends of the water. So the chlorine is no longer needed to be attracted to the sodium because its charge is being canceled by all the waters. This is also why you become so dehydrated when you drink salt. Literally, water molecules, it took just a 1 unit of the NaCl apart. And then what factors are affected by the particles in the solute? The freezing point goes lower. So this is why we put road salt on the road, to lower the freezing point and reliquefy the ice that's on the road. So if pure water froze at 0 degrees, by lowering the freezing point to negative 30, then at 0, it's now a liquid. And we raise the boiling point up higher, so instead of boiling at 100, it may be boiling at 110. Okay, one of the important compounds that ionizes and breaks into ions are acids and bases. Both of them are ionic compounds. So one of the reasons why we studied solutions in dissolving here is to understand how just regular compounds ionize, and then that applies directly to acids and bases. Okay, so the first one we're going to cover is an acid. And an acid is a compound that contains at least one hydrogen ion, and that's really what makes an acid, is that it has a hydrogen ion. So an acid has a H plus ion. Okay, so it creates an ion, and it turns indicators a different color. Now I want to come down here to this part of the notes, and acids turn blue litmus paper red, and bases turn red litmus paper blue. Okay, now the first time you're looking at it, it's like, how in the world am I ever going to remember this? The color that the paper turns is the same as the last letter of whatever they're asking you about. So acids turn it red. Bases, it ends with an E, turn it blue. So that's how I always remember. So it's going to end up the color that's the same as the last letter of what they're asking about. So what color is some acid? Well, the choice is red or blue. Red has the same last letter as acid. Bases, and what color does it turn? The choice is red or blue. Base ends with the E, blue ends with the E, so you just remember it's the same as the last letter. Okay, so they turn an indicator red. Okay, and then there's some common acids that we have around. Citrus fruits have citric acid. You may have heard that before. Some people are allergic to the kind of acid that's in milk products. It's called lactic acid, and they're lactose intolerant. Vinegar and pickle foods have acetic acid in them. Okay. Now, a base is a substance that contains a hydroxide ion. So when we did the polyatomic ions, we studied hydroxide ions. They were OH negative. and so there's still a OH negative, and so the base creates a OH negative, a hydroxide ion. So hydrogens are H positives, bases are OH negatives, creates a hydroxide ion, and they turn the indicator blue. So remember I said that one of the reasons why we studied dissolving in the last part of this unit was to understand how things ionize, and this is why, because acids ionize into hydrogen ions and bases ionize into hydroxide ions. So this is a key characteristic. And then there are some natural indicators that we see around. Now, the indicator is like this litmus paper. So it's actually called a phenol, but there are a lot of things that have natural indicators in them. Okay, now these are called hydrangeas, and you may have seen these growing, pretty popular in people's gardens. The flower petals have a natural indicator in them. So when they're growing in a neutral soil, the flowers are white. Now, a lot of people think that the different colored flowers are different plants. No, it's all the same plant, and the flowers turn different colors depending on the soil that you have it planted in. So you can make this white one have red flowers or have blue flowers just by planting it in a soil that was the pH is a little high and it's basic. So if you take that same plant and plant it in the soil and the soil is a little basic, the flowers will be blue. So the petals of the flowers actually have the indicator that's in the litmus paper. So bases turn it blue, acids turn it red. So you take that white flower plant and you plant it in soil that's slightly acidic, and it'll have red flowers. Okay? So bases are blue, acids are red. And then the pH scale goes from, it uses those same indicators. It goes from acid is the most red down here with hydrochloric acid, and then things like hydroxide turn the indicators that are very basic, they turn the indicators blue. Okay? So the properties of acids and bases. Okay? Acids taste sour, and so we say things like citric acid and pickles. Okay, those things are sour. Typically, acids taste sour. So things like oranges, warheads. I wanted you to look on the ingredients of those warheads, that candy, and it says it contains malic acid, and then citric acid. So they're using the kind of acid that's in citrus fruits like oranges and lemons, grapefruits, all those sour things. And then down here, it says eating multiple pieces within a short period of time can cause a temporary irritation to sensitive tongues and mouths. So if you've eaten a lot of these sour candies, and it's not just warheads, you notice after a while that it starts to bother your skin and your skin feels sore. This is because acids are corrosive and they can damage skin and tissue. They also eat through metals. And we know that acids turn indicators red. The key characteristic that makes an acid is it produces hydrogen ions, which are H plus when dissolved in water. Okay, so we have some acids and bases over here on this little pH scale, and it shows we have this lemon juice over here. So things that are slightly acidic, like milk with the lactic acid, bananas, tomatoes, grapes, lemons, these things that taste sour, stomach acid, which is the acid that breaks down food, help with digestion, and then things that are slightly basic, eggs, baking soda, soap. You notice there are a lot of soaps that are basic. Okay, soap, ammonia, bleach, oven cleaner. Okay, those things are typically bases. So properties of bases. Well, they start off as crystalline solids when undissolved. Okay, so remember the crystalline solids were ionic compounds. And then all these soaps feel slippery when they're in solution. Okay, and when there are a lot of soaps that are basic. So you think about, when you wash your hands, they feel slippery. Okay. Bases are also very corrosive. So like oven cleaner and drain cleaner can be very corrosive, like this Drano. Okay, they turn indicators blue, and they taste bitter. They produce hydroxide ions, or OH negative, when they're dissolved in water. I want you guys to pause the video here and answer these questions on your own. Okay, so welcome back. You should have taken a moment to answer these questions. An indicator indicates whether or not a substance is an acid or a base. It's an organic compound like we saw in those flowers. There's also indicators in cabbages. That's where the purple bluish color comes from. How can we tell something is an acid? It'll release hydrogen, or H plus ions. How do we know if something is a base? The hydroxide, or the OH negative ions. What color does a base turn an indicator? Base ends with a E, so our color choices are red or blue. Blue ends with a E, so it turns it blue. What color does acid turn the indicator? Acid ends with a D. Our choices are blue or red. It turns it red. They both end with the same last letter. And the properties of acids that we just covered. Okay, they taste sour. They're corrosive. A lot of times they're used to clean metals. They'll eat through particularly metals. They turn indicators red. They make hydrogen ions. Properties of bases we just learned about. Bases are bitter. They turn indicators blue. They feel slippery in solution. A lot of them are soaps. They're also corrosive like acids. They make hydroxide ions. And they're crystalline solids when they're not dissolved. They often have hydroxide in their name. So like drain cleaner is called ammonium hydroxide. I hope you're having a great day, and we'll see you next time.